So hello guys, in this video we will demonstrate the working solution of the task 3.1p in which we will use the IFTTT and use our BH1750 setup like this I am showing you with these pins attached at, at their appropriate places with Arduino. And as you can see, this is my code. So particularly in this code we are just trying to build up the connection using our Adafruit IO, which in this will act as a mediator between the IFTTT and my BH1750 sensor. So this is my Adafruit IO, which will take the readings and will give the instructions whether the sunlight has stopped or sunlight is still going on, and then pass it to the IFTTT. And in this code we have just given our keys and our all the addresses to in order to connect with the Wi-Fi and my AI of my IO key and all the code in this particular lines. And this is our starting lux. Starting lux means the illuminance of the light that it will receive. As you can see that it is receiving the light of a particular luminance, and if you will cover it, it will reduce its illuminance. And in this we are just giving it instructions to connect to the Wi-Fi, and these lines will send the particular request or the instructions whether the light is on or off to our Adafruit IO. And this is our setup, which will tell us whether it is ready or it has connected. And in this loop it will just sense whether how much luminance it is getting. As we can see, serial print lux, it will print the lux on serial monitor. So this is the code, and this is our Adafruit IO AI, and it will receive the data in this. And this is our IFTTT, which will it is the applet for if the sunlight has started. As we can see, we have already run it it has run 7 times. It will send us the email through after getting the instructions from Adafruit IO, and it will give us whether the sunlight has started. And similarly we have created a second applet which will give us the instruction whether the sunlight has stopped. As you can see, it has given 725 times, which we have recorded. So let's run this code, and we'll just quickly change the Wi-Fi details as we have connected to a different Wi-Fi. Now as we have changed our connection details, now we can see the code is being run. And if you will check the serial monitor, it will just detect the lux, and you can see it is detecting the lux. And as soon as it detects a lux greater than 100, it just immediately posts it to the Adafruit IO, and we can see that it has posted it if the lux was less. And if we will just cover it, it will also just post it, and I can show you. You can see the sunlight has started at 121 lux, and as it was covered, so it gave us a lux of sun stopped, and it has just given that sunlight has started, and it has just given us the instructions. And similarly we can see that we have got the notification of sunlight stop in our email, which is our email. You can see we have received the notification from the Adafruit IO, and as we have already run it previously, so you can see as I have shown you how the mechanism works. So this is the latest email IFTTT. I have shown you the previous emails. These are the mail which I got previously, but this is the latest email in which I have shown you how that the sunlight has stopped, and it is 12 lux, which is below the 50 lux, which is our threshold of for below. As you can see, we have given it 50 lux is a stopping lux, which means that sunlight has stopped and sunlight is not there. So in this IFTTT, as it is a polling trigger, Adafruit IO is a polling trigger, and we don't have a pro version of it. So it means that it will check in every 1 to 2 hours, and it is not very real time process if we don't have the pro version, but it still works. And as it is a polling trigger, so it works slowly, and we will get emails in a delay. As I have shown you that this is the 12 lux which I got at 2:08, and within 10 to 15 minutes of delay, I got the mail that sunlight has stopped. You can see it is the stopping lux of 12 lux, which Adafruit IO received. And similarly, I got a mail from here. So thank you.